Hello everyone. In this video, we are going to design and develop a JavaFX based arithmetic operations application from scratch. It demonstrates the use of JavaFX controls, layouts, event handling, input validation, and arithmetic logic in an interactive and user-friendly manner. Let us discuss about what are the important components and logic is developed from this application. In this application, we accept two numeric inputs from the user using text field controls. The result is displayed using separate non-editable text field, and we provide 6 buttons for performing various arithmetic operations like addition, subtraction, multiplication, division, modulo division, and power operation, and all these components like text fields, buttons are arranged using grid pane layout. Grid pane layout which arranges the components in matrix formats in terms of rows and columns with the proper spacing and respect to center alignment. The user inputs are considered through text fields. These user inputs are validated. If any text field is empty, the operation is not allowed. And we define the event handling with every button for performing 6 different operations. This event handling in this demonstration, which is developed by using lambda expressions. This application supports both integer and floating point calculations wherever it is required. Let us go for understanding of grid pane. How the grid pane is used in JavaFX application. Already we know that grid pane arranges the components in matrix formats. So the grid pane is defined in javafx.scene.layout package as a grid pane class. Like this, we can create the grid pane object, and if you like to set the horizontal gap for the grid pane, we will call the set hgap method for specifying the horizontal gap. The syntax for this method is public void set hgap for setting horizontal width, double width, next for setting vertical gap from one component to another component, we will call the public void set v gap double height. So by using these two methods from grid pane component, we will set the horizontal gap and vertical gap maintaining among the different components. And next, how the graphical user interface elements are added to the grid pane. So in order to add graphical interface elements to the grid pane, we will call the add method from the grid pane. Add method from the grid pane. The method is public void add. As a argument, the first argument we will specify the which user interface control is added. That object is referred. As a second argument, we will mention the column number. As a third argument, we will mention the row number. So how column value and row value are assigned when node component is added to grid pane. Suppose for label L1, that is added as gp dot add of L1 comma column value is 0 and row value is 0. Similarly, for the text field T1, the column value and row values are added as component is t1, column value is 0, column value is 1 and row value is 0. For L2, the component is L2, column value is 0 and row value is 1. For text field 2, component is T2, column value is 1, row value is 1. For text field for label L3, component is L3, column value is 0, row is 2. For text field T3, for result, component is T3, column value is 1 and row value is 2. So in the same way, for button B1, component is B1, column value is 0, row value is 3. For subtract button B2, column value is 1, row value is 3. For multiply button, component name is B3, component reference is B3, column value is 0, row value is 4. For division button is B4, column value is 1, row is 4. For button modulo division, button is B5, column value is 0, row is 5. For button B6, power button object is B6, column value is 1, row is 5. So this is the way we will consider the column values and row values for gp.add method. So with that, how the column values and row values are considered for grid pane is understandable for us. If it is understandable for us only, then we can able to arrange the components in grid pane in JavaFX application easily. If it is not understandable, the arrangement of components in JavaFX scene as well as developing the application, that is very difficult for us. So that's why understanding this one is very important in development of JavaFX application. Let us go for development of JavaFX application. Take the file as arithmetic.java. Save the file as arithmetic.java. Save file as Java source file. Now import all packages. Import JavaFX.application. Next import JavaFX.stage. Then import JavaFX.scene. Then import JavaFX.scene.layout. Then import JavaFX.scene.control. Import JavaFX.event for handling JavaFX events. Then import JavaFX.geometry. import JavaFX dot collections. So this is the way important packages which are imported for working with calculator application. Let us define the public class arithmetic extends application. Take three labels L1, L2, L3. Take 6 buttons B1, B2, B3, B4, B5, B6. Take 3 text fields, text field T1, T2, T3. Then take the grid pane reference variable for creating grid pane. Grid pane reference variable declare as GP. Then declare scene variable scene S. Now define the init method public void init. Then create a labels. L1 is equal to new label, enter number 1. Then create label 2. L2 is equal to new label, enter number 2. Create label 3. L3 is equal to new label result. Next we'll go for creation of text fields. T1 is equal to new text field, T2 is equal to new text field, then create T3. T3 is equal to new text field, then create 6 buttons. B1 is equal to new button, take the button name is equal to addition, then copy the same for 6 buttons by changing name after pasting 4, 5, 6. Now take buttons as B2, B3, B4, B5, B6. Here subtraction, multiplication, division, modulo division, power. So this is the way we created 6 buttons. Then we create grid pane object. GP is equal to new grid pane. We set the horizontal space and vertical space for grid pane. Set H gap 25, GP dot set V gap 25. So likewise we are maintaining the horizontal space and vertical space among components are added to grid pane. Then set the alignment for grid pane. Set alignment POS dot center. So that means grid pane is arranged on the center of the JavaFX. So next call the GP dot add of L1 comma 0 comma 0. So now we are going for adding controls to the grid pane. So how we demonstrated here, in the same way we are adding components to the grid pane. The column value and row value, how it is considered in this table, in the same way in the code also we will add the column value and row value for all respective controls. Now we add gp.add of L1, that is text 1, column value is 1, row value is 0. Next, for second line contains the label 2 and text field 2. Label 2, column value is 0 and row value is 1. For text field 2, gp.add of t2, column value is 1, row value is 1. For result text field, gp.add result label L3, column value is 0, row value is 2. For result text field is T3, column value is 1, row value is 2. For addition button B1, column value is 0, row value is 3. For subtract button is B2, column value is 1 and row value is 3. For multiply button is B3, column value is 0, row is 4. For division button B4, column value is 0, column value is 1, row value is 4. For modulo division, button is B5, column value is 0, row is 5. For power button is B6, column value is 1, row value is 5. So this is the way all components are added to the grid pane with respect to row value and column value. At any case, row value and column value not considered correctly, not assigned correctly, the arrangement is destructed. Next, we'll go for definition of start method. Public void start, stage st, throws exception. So let us go for defining the event handling for all 6 buttons. Here event handling is handled with lambda expressions. For every button, we'll call set an action method for event registration. As an argument of set an action method, we will define lambda expression in order to handle action event when button is pressed. Now we'll go for defining lambda expression. So when button is pressed, we will check whether in the first text field and second text field data is input is entered or not. If input is not entered, the event which displays the please enter number 1 or number 2 and number 1 and number 2 in the text fields text field 1 and text field 2 without performing addition action event while clicking on addition button. So this means when input is not entered, addition operation is not performed. That validation we are performing here. If t1.getText is empty or t2.getText is empty, meaning of this one is whether t1 or t2 text field is empty, then again we'll go for checking exclusively for t1 text field, t1.getText is empty. Let me display the message in the same text field, t1.setText, please enter number 1. We'll close the condition. Next we'll check for t2 if t2.getText is empty. The isEmpty method checks whether text field contains input data or not. If it contains input data, it returns true. If it contains if doesn't contains input data, it returns true. If it contains input data, it returns false. So the isEmpty method checking empty or not. That means whether input is not there or not. If input is not there, it will prompt the text message t1.text, please enter number 1. Here we'll take t2.setText, please enter number 2 for text field 2. So this is the way we are defining the logic for to check whether text field 1 and text field 2, text field 1 or text field 2 contains the input data or not. Let us close the condition, this if condition, outer if condition. So if this condition is failed, meaning of that is text field 1 and text field 2 entered with input data. So let us go with string str1 is equal to new, get the text data t1 dot get text, then get the str2 get the data from text field to get text, the get text method which returns the input text data from text field. Next integer n1 is equal to integer dot parseInt of str1. So this method is used for returning the integer data for text field 1. Integer n2 is equal to integer dot parseInt string 2. This is returning the integer data for which is entered from the text field. Now we are performing the integer n3 is equal to n1 plus n2. Now the result is generated. So the text field 3, that is result text field, which is added with the result data set text of n3. So the setText method accepts only string data, so that's why we are creating string as a argument. Now we'll close the else block. Next will close the set an action met will close the lambda expression. Next will close the set an action method. So this is the way we define the logic for the addition button. In the same way, we will define the logic for subtraction button, multiplication button, division button, modulo division button and power button just by changing button names. Next, inside we will go for performing the different operations. We will take button B2. Button B2 is intended for subtraction operation. Let us take, instead of n1 plus m2, take n1 minus n2. So next to take the button B3. Button B3 is intended for performing multiplication operation. When button B3 is clicked, multiplication operation is performed. So here, instead of plus operator, take the star asterisk symbol for performing multiplication operation. So next, button B4 is intended for performing the division operation. Let us take n1 by n2. So here perform the typecasting for exact division result. Take the n3 as double instead of integer. Next, go for button B5, which is intended for modulo division operation. Button B5 is intended for modulo division operation. Let us change the n1 modulo division by n2. Next, define the button B6 for power operation. Here, instead of n1 plus n2, call the power function from math class, math dot power of n1 comma n2. The n1 refers the base and n2 refers the power. So this is the way we define the event handling for all buttons: addition button, subtraction button, multiplication button, division button, modulo division button, power button. Button B1 specifies the event handling for addition button. Through button B2, we are performing event handling for subtraction button. Through button B3, we are performing event handling for multiplication button. Through button B4, we are performing event handling for division button. Through button B5, we are performing event handling for modulo division. Through button B6, we are performing event handling for power operation. So this is the way we are defining the event handling for all 6 buttons. Then we will create a scene object. S is equal to new scene grid pane comma. We will specify the size of the scene 700 comma 700. The first 700 specifies the width, second 700 specifies the height. Next, set the title, arithmetic calculator. Then we'll set the scene to the stage, set scene of S, then call the show method. Then close the start method and now define the start method and now define the main method for launching of JavaFX application. We know that definition of main method in JavaFX application is completely optional. If you are not defining, automatically the default main method is called from JavaFX application and automatically application is launched. Close the JavaFX application. Now I would like to go for checking errors. This program took 169 lines. Let's we check what are the errors are happened and how the program is compiled and executed. Let us take JavaC arithmetic.java. So we got error at the beginning. JavaFX.scene. Let's saving the program. For GP, we are missing semicolon here itself. Then we got error at public static void main. Okay, we additionally added the void keyword that created error for us. Now we'll compile the program again. Okay, we got error at text field. FIE text field. Then we go for compiling the program. Save it. Compile it. So power operation. Let us take it as a double. Power function returns the double value. So that's why entry variable we declared as a double. Program is compiled and running the application. So now the program is successfully compiled and executed. Let us go for entering input number 1, 2, number 2, 3. We press on addition, result is displayed. We press on subtraction, -1 result is displayed. We press on multiplication, 6 is displayed. We press on division, division value displayed. We press on modulo division value displayed. We press on power value is displayed. So totally all operations are successfully computed. Next, without entering input, we check how the operations are executed. Okay, so we are not entering input. Without entering input, we are trying to perform the operations. So that validations are performed. Please enter number 1. Please enter number 2. So here number 2 is missing. We change the code. Number 1, number 2, number 1, number 2, number 2, number 2, number 2, number 2. So this is the way we are saving the code again and close this. Now again compile the program and run the program. So without entering input, we try to execute the power operation. So it asks, please enter number 1 and number 2. Now I would like to go for executing by entering input number 1 and number 2. When I am clicking on this, addition operation performed. When I am clicking on this, subtraction operation performed. When I am clicking on power operation is performed. So this is the way we performed the all arithmetic operations, how we demonstrated in the problem statement. So in this hands-on practice, we understood how to take the multiple controls for creating one graphical interface. We considered label, button, we added label, button, text field, and all are arranged through grid pane. The grid pane calls the grid pane arranges the components in matrix format in terms of rows and columns. Then adding elements to the grid pane somehow complex. So understanding that matrix structure is important here for arranging components to the grid pane. After then, in the start method, we are defining the event handling for all buttons: addition, subtraction, multiplication, division, modulo division, and power for every button. Before performing every arithmetic operation, we are checking whether input is entered in the text field 1 and text field 2 or not. If input is not entered, it asks, please enter number 1 and please enter number 2 for all operations. Here, for handling events, we have three methods. One is anonymous inner classes, lambda expressions, and method references. For simplicity of development, we use lambda expressions. This is the way we understood how to develop a simple arithmetic calculator using different JavaFX controls. Thank you for watching this video, and in the next video we would like to go for demonstrating how to work with combo box and its hands-on program. Thank you for watching this video.